Imagine standing on solid ground when suddenly everything starts shaking. Why does this happen? What causes earthquakes deep beneath our feet? In this video, we'll explore earthquakes from a geological perspective and understand the forces that constantly reshape our planet.
To understand earthquakes, we first need to understand Earth's internal structure.
Let us zoom directly into the Earth's solid crust. Here, vast continents and deep oceans take shape. This is the vibrant, living surface of our world.
The crust and uppermost mantle together form the lithosphere. The lithosphere is broken into giant moving sections called tectonic plates.
Although we cannot feel it, these plates move a few centimeters every year.
But why do these massive plates move? The secret lies deep within the mantle. Great circular convection currents drive them.
Hot material rises, and cool material sinks. At convergent boundaries, plates move toward each other.
Most earthquakes occur at the boundaries between tectonic plates.
When continental plates collide, massive mountain ranges can form.
In subduction zones, one plate sinks beneath another. These regions generate some of the world's largest earthquakes. At divergent boundaries, plates move away from each other. New crust is created as magma rises between separating plates. Transform boundaries occur where plates slide past one another. Friction prevents plates from moving smoothly. Over time, stress accumulates inside rocks. The rocks slowly deform and store energy. This process is known as elastic rebound. A fault is a fracture in the Earth's crust, where movement occurs. Normal faults form when rocks are pulled apart. Reverse faults form when rocks are pushed together. Strike-slip faults involve sideways movement. When stress exceeds rock strength, sudden rupture occurs. The stored energy is released instantly. This energy travels through the Earth as seismic waves. P waves are the fastest seismic waves. S waves arrive later and produce stronger shaking. Surface waves cause the most visible destruction. The earthquake begins at a point called the focus. The point directly above the focus is the epicenter. Magnitude measures the energy released during an earthquake. The Richter scale was one of the earliest earthquake scales. seismic waves. The recorded data is called a seismogram. Aftershocks occur as rocks adjust after the main earthquake. Large undersea earthquakes can generate tsunamis. Earthquakes can trigger dangerous landslides. Some earthquakes are preceded by foreshocks. Today, scientists use the moment magnitude scale. Water-saturated soil may behave like a liquid. The collision between the Indian and Eurasian plates creates powerful earthquakes.
Scientists monitor earthquake activity continuously. Pakistan experiences earthquakes because it lies near active plate boundaries.
Despite advances in science, accurately predicting earthquakes remains difficult.
Earthquakes occur when tectonic plate movements build stress that is suddenly released along faults. The Earth beneath us is always moving. By understanding the geology of earthquakes, we can better prepare for natural hazards. Don't forget to subscribe for more geology and earth science videos.